My name's Trevor Newell. I'm the Distribution Sales Director for Seal for Life Infrastructure Coatings Group. So we'll talk a little bit today about liners for dynamic cargoes. I gave this presentation at the Great Lakes AMP chapter about a month or so ago with Doug, and we'll kick it off. If there's any questions, please feel free to go ahead. No, it's not going to go. There we go. So the goal today is to define the challenges of selecting the proper liner coating for dynamic cargo storage and containment and review solutions that meet service-specific challenges. So we'll talk a little bit about what are dynamic cargoes today, challenges to address in liner selection, available technologies currently, site-specific considerations, and inspection and testing as well. So what is a dynamic cargo? Well, dynamic cargo is a cargo that is characterized by constant change, activity, or progress. So the environment may change, a process may change, a system may change, or the actual cargo may change. As we all know, sometimes it's not always easy to adapt to change. So what are some typical cargoes that we would see for dynamic? That could be crude oil, refined petroleum products, could be organic chemicals, inorganic chemicals, vegetable, animal oils, fats, processed water, miscellaneous cargoes. What happens when you need that one rail car or tank that can carry multiple cargoes back to back at different temperatures? Now, there isn't always one coating that's going to fit everything, but there is some coatings that can fit for multiple cargoes, and that's what we're going to be talking about further today. So types of dynamic cargo containment. It could be secondary containment, which you may have storage tanks that hold 4 or 5 different types of chemicals or liquid storage. Barge holds for containers and ships. They're to be carrying dry food one day, and the next day they could be carrying chemicals in there. Rail cars and tankers. These can be switched out quite rapidly back and forth in a rail car. Wastewater and basically storage tanks themselves in general. But no matter the type of containment, you need to select the correct coating to protect the steel, withstand exposure to all possible cargoes, provide easy cleaning or hold up to required cleaning, and protect the next cargo from contamination. So at any time that we're going to switch out cargoes, there's always a cleaning process in between to ensure, once again, you don't contaminate the next cargo and you don't cross. Could be different chemicals where by themselves they're fine, but all of a sudden 2 mixed together, you're going to have a problem and it could attack the steel. So typical challenges: chemical composition, harsh cargoes, exposure to high temperatures, exposure to humidity from condensation, seawater, salts, oxygen, mechanical impact, falling tools, cleaning operations. All these things factor into affecting a coating and a corrosion cycle on steel itself. Other general challenges: cargoes mostly carried according to manufacturer cargo resistance lists. Applications are completed according to guidelines, no non-conformances. Tank cleaning processes not defined or confirmed. So everybody likes to say they know what they're carrying, but sometimes we have customers that have cargoes that aren't totally defined. So what we often discover is higher storage temperatures for more extended periods of time. They may say it runs at a certain temperature. We'll always ask what the max operating temperature is so we know what that temperature is never going to get over. Some coatings are not approved for alternative surface prep or application. Single leg, plural component pumps, different types of surface prep from an SP2-3. I would hope most specifications you're going to see in immersion are going to be a near white or a white metal. And incorrect cleaning procedures. So that would be, once again, in between the cargo storage, there's specific instructions we would give for clean out of these vessels, tanks, and barges. So what type of available technologies do we have today? Well, it started out in the 40s with zinc silicates, great resistance to pure chemicals and solvent, but limited by pH range, typically 6 to 9. Pure epoxies back in the 50s, limited resistance due to low cross-link density. So that internal network, when you're chemically curing, you have a daisy chain, which they call cross-linking. The more cross-linking you have, the harder it is for moisture or the cargo to make its way through to the steel substrate to start a corrosion cycle. Phenolic epoxies, Novalacs in the 60s, vinyl ester, Novalac vinyl esters, 70s and 80s. In the late 1980s, aromatic urethanes, or 100 solids, flexible polyurethane, and of course these are aromatic thick film, not aliphatic that you would use for color retention, gloss, and all those wonderful things on cars and structures outside exposed to the sun. And solvent-free epoxies. Of course, starting in the 90s, now you're starting to get into those higher cross-linking, greater density and permeability, stopping that moisture from getting through the coatings, and getting solvent-free. So you're inside a tank, it's 100% solids. Now you don't have a VOC issue inside the tank that can create other health hazards for applicators. And epoxies aren't all the same. You have all different types of epoxies that you have to know as a formulator what these epoxies do. Biz A is a good acid and solvent resistance. A Biz F epoxy is excellent for alkali resistance and good acid solvent resistance. So you can see some of the differences already. You get the Novalacs, excellent thermal and chemical resistance, but maybe not the best impact or flexibility. Curing agents, you can have polyamine, polyamide, cycloaliphatics. So these are all mixed together to actually make that internal lining coating. So there's different formulations available. So for Seal for Life, our chemical resistant coatings and linings are formulated to provide premium cross-link density. That's the biggest thing with a lot of our products, where they will fit for dynamic cargo. We have thick film Novalacs, thin film Novalacs, thick film aromatic urethanes, and we have hybrid products, as we just mentioned, Biz A, Biz F, Novalac, different curing agents. Once again, to be able to withstand that cargo that the customer is going to be running, and different ones down the line. Service life expectations. A coating system service life is dependent on many factors. Site-specific service conditions. No site's going to be the same. It could be 20 feet over in another tank, but no site or service conditions are going to be exactly the same on any tank. You could have weather changes, you could have cleanliness, you could have a new tank, it could be an old tank. These are all going to be different. Specific coating systems, that's going to tell you what your service life expectation is. We know that as formulators from testing these products, how long they're going to last in a certain environment. The applicable surface prep application is critical in surface prep to get proper. Exposure and cycling. So what are these chemicals that we're going to expose the product to? Does the temperature cycle? Does it get hot? Does it get cold? Does the steel expand, contract? These are all things that we need to know to give you the proper service life. And of course, proper cleaning, inspection, and maintenance. No coating is going to sit there for 20 years and be great by itself. You need to have, cleaning, once again, in between cargoes. Inspection and maintenance is critical. Inspect that tank. Somebody could have some impact damage from the outside that cracks the lining on the inside. You want to be able to inspect that periodically to fix repairs when required as part of the maintenance cycle. So we won't spend a lot of time on inspection and testing, but this is the critical part. On application, a lot of us know all of these things: sling cycrometers, soluble salt test kits to test the substrate, viz guides, hardness testers, holiday detectors, technical data sheets, SDS. These are all things the applicator is going to use, or an inspector, when they're on the job site to ensure that the proper application of the product is done and followed to the specification. What we need to do before we even bring these coatings to the field for dynamic cargoes is, as a coating manufacturer, have our own internal. So we will test all these products for all the different cargoes that we're going to be looking at. And we're going to send it out to third-party testing so that we have those test labs that actually do the testing and tell us and customers themselves that, yes, what we're reporting is correct. And we substance that with our third-party testing. And this is critical to be able to understand what a coating can and can't do. No point listing them all, but chemical immersion, cathodic despondent, adhesion, impact, salt spray, these are all critical things for a coating manufacturer to understand to be able to provide the proper product for the specification and the cargo. So getting towards the end, just a little bit to go through, but just wanted to show you some project examples. So this is a internal on a barge as well. So you can see some of the baffles, supports, piping that come in. This would be a standard coating that we would use in barges. Once again, that accepts dynamic cargoes, different cargo changes, and is good up to 350 degrees Fahrenheit. In not every cargo, but most chemical cargoes. Here's secondary containment. Once again, not as critical as primary containment. By law, secondary containment, if you have a spill in one of these vessels, you need to clean that up in 72 hours. A lot of people don't. A lot of areas where you see, I don't know if you can see my cursor here, but where one of the pipe and the drain is, anywhere where there's a loading and unloading of these chemicals in this tank, usually have leaks, drips. We'll find it all the time that it's dripping in one spot from where the pipe inlet or outlet is, and they never clean that up. So we take that into effect as well, knowing that it should be cleaned up in 72 hours, but chances are small areas are not going to be. Here's just a large storage oil tank that's been insulated and cladded. Once again, this is a different environment. It's got insulation and cladding around it. It's going to retain the temperature and repel outside temperature. So it's going to be more specific on temperature and not cycle as much. This is just a large bulk storage tank. Once again, we have customers that rent out tanks. They'll rent them out to the oil field. It could be for frack water. Well, you get frack water back and it could have all different types and percentages of chemicals in it, depending on what's in the ground and what they're using, different pH ranges. So these are all areas, once again, where these products are used, but you have to ask those questions. You have to ensure, and that's where we come in as coating manufacturers. Are going to ask a million questions. Customers may be going, oh man, like, what do we need to know all this for? Well, there's a reason, and that's so that coating that we're looking at lasts its intended period, what it's supposed to. And we can tell you that based on the technologies that we just talked about today.